to my channel. This is Great Tutorial, and what I do here is solve technical drawing problems and also provide very important information that can make use of for you to have a better performance in your technical drawing examinations. You are watching my video for the first time, you're a technical drawing student. I want to ask you to subscribe to this YouTube channel, put on notification bell so that whenever I upload a new video, you'll be notified, and help me to share my videos with your friends who are technical drawing students. And very important, as I usually say, you need to practice this subject. When you practice it, you surely master it. Okay, right now what I want to do here, I want to show you how you can use your drawing instrument to produce the isometric view of this object whose orthographic views are given. As we have here that the sketch in figure 1 shows 3 views of a block used to answer question 1. Okay, so looking at these views that we have here, which I believe that you will have known the type of orthographic views that we have here, as you can see here. So it means that what we have here, we have the plan, we have the front elevation, and we have the end elevation here. So when the views are arranged in this form, it means that this type of orthographic views are given in third angle projection when the plan is above the front elevation, though the end elevation is always beside the front elevation. So these views are given in third angle orthographic projection. So we want to put them together for us to produce the isometric view. This is a wild question, and this is on paper 3, and here we are asked to sketch it freehanded, which I've done. But I want to use the drawing instrument to produce the isometric view, because I know that I can bring back this type of question or this same question and ask you to use your instrument to draw it instead of freehand sketching, which I've done. So you can watch that video. So let's look at what we need to do here. The dimensions are given, as you can see, but very important that we are told that this is the lowest point. This is the lowest point, so we need to take note of this lowest point, and that is where I'm going to start from. So first of all, what I want to do is to produce this plan, then we build it up to bring out the front elevation and also to get the end elevation. Let's start. Okay, so the first thing that you need to do here, as you can see what I'm doing here, is that you draw horizontal line. So draw a horizontal line like this. So this is okay. So with this, with your 30-degree set square, so you draw a line in this direction from this point, and you also draw a line in this direction like this. All right, so with this line that we have drawn, so the next thing I'm going to do, as we are told that this is the lowest point, so this point here is the lowest point, so I'm going to write here as point X. I'm going to write X here. As you can see here, I'll write X at this point, so that is the lowest point, X. So what I want to do, as I've said, is that I want to produce this plan. I want to produce this plan with this lowest point X, which we have already gotten. So distance from here to here, as you can see in dimension, is 15 millimeters. So I'm going to take a measurement of 15 millimeters. I'm going to take a measurement of 15 millimeters from this point. So this is 15 millimeters here. So here is 15 millimeters. So I will draw this line in this direction. So I'll take it in this direction. So it goes like this. Okay. So having drawn that, so the next thing that we have here, so we have the distance from here to here is 20 millimeters. So I will take a measurement of 20 millimeters here. Take a measurement of 20 millimeters. So this is 20 millimeters. So I will also draw this line, so it will go in this direction. I want us to take our time to analyze everything. I don't want us to rush, so it may take time, but it's very important that we are able to we understand it. So we draw this line in this direction. All right, so now the next thing that we are going to do is that, so distance from here to here is 56 millimeters, and we are told that this is 14 millimeters. Distance from here to here is 14 millimeters. So if you subtract 14 from 56, that will give us 42. It means that from here to here is 42 millimeters. So I'm going to take a measurement of 42 millimeters from here. So this is, okay, I'm using my set square to take the measurement. So this is 42 millimeters here. This is 42 millimeters. So then that 56, I will take it at the back here. So let me take that 56. So at the back here, so this is 1 2 3 4 5. So 56 is here. So this is 56. So with my set square, I'm going to transfer this line. I'm going to transfer it to this side here. As I said, that the first thing I'm doing here is to bring out the plan, so as given. So also from here I will draw this line. So from here I will draw this line. So this has to, I will draw this line, So let me take this back. So I've not brought out what we need. So now let's look at the next thing that we have here. Let's get total distance from here to here. This is 20 from here to here. 20 plus 15, that's what that is 35, and plus 5, that is 40, plus 20, that is 60. Then we have 65 millimeters. So total distance is 65 millimeters. So which I'll be taking from here. So 65 millimeters from here. So this is 65 millimeters. So this is 5 millimeters. I'm going to take it. So I will draw it from here and take it here like this. Okay, so this is 65 millimeters here. So the next thing I'm going to do is that, so I've drawn the plan, as you can see. So the plan is already out. As you can see it here, is already here, if you look at it very well. So the next thing I'm going to do is that I need to bring out the front elevation, as we can see here. So we have this rectangle, and we have this rectangle, and we also have this rectangle here. So let's bring it out, and you see how I'm going to take it. So from this point here, draw a vertical line. From this point, draw a vertical line here like this. Draw a vertical line. So from this point, I will also draw a vertical line here like this. So at this point, I'm not going to draw a vertical line, but I will come here. I will take a vertical line here. So that one is not compulsory. So I will take a vertical line at this point. Okay, so I will come here also. So I will draw a vertical line here like this. Okay, so here also I will draw a vertical line. Just follow the way I'm doing it. It's very, very simple. So next thing that we are going to do is that in the front elevation, so we have that distance from here to here is 45 millimeters. So I'll just take 45 millimeters only on this point here. So this is 45 millimeters. So I will transfer this point to other side. So with my set square, so I will transfer this. So just look at me. So I'll transfer it here. So then from here, so this will come to this point here. And then from here, I'm also going to draw a line. So it goes like this. So then I will transfer this from this point. Okay. All right, so on this line, I will take 56. On this line, I will take 56 millimeters here on this line. So that is the distance from here to here. I will take that 56. So which has already been taken. Oh, okay, maybe I don't need to take that. Just let me draw this vertical line. Let me extend it. That should go up. So there is it. Okay, so now I can transfer this now from this point. From this point, I will transfer this. So bring it forward like this. And from here, so I will take this. So take it to this side. Okay, then I will join this together. So join this together like this. So this is it. So look at what we have here. So we have brought out this part here. This rectangle is here, but it remains this rectangle that we have here. So if you look at, so first of all, so I need to take this point here. I need to take it up. So take this up like this to this point. Okay, now so why do we have to bring out this point? So look at what we have here. look at what we have here. So we have this rectangle, which is here as I said. So this rectangle that we have here in the front elevation, we can assume that this is the rectangle, but it is not actually this. So we come to the end elevation. If you look at this line in the end elevation is when we are looking at this object in this direction. We are looking at it in this direction. So we are going to see this line. We are going to see this line like this. This is a non-isometric line. So how can we produce this line? So what we need to do is that I will join this point and this point together. We cannot use our set square to do that because it's a non-isometric line. It is not inclined at an angle 30 degrees. So I will join this line together. This point, these 2 points, I will join them together. And also this point, I will join them together. So if you look at what I've done here, you'll have seen that the shape has come out already. Look at what we have here. So this is the shape of the end elevation. In the end elevation, I have what? I have this triangle. I have this triangle. This is the triangle. Then I also have this triangle on this part. So this is the triangle. Okay, so if you look at the front elevation, this triangle, this rectangle that we have here, it is meant for this rectangle here. So to be shortened, it will not be as long as this in the front elevation, to be shortened because this is an inclined surface. It's an inclined surface, so I believe this is clear to you. But let's bring out what we have. What we have before we continue. We only need to put one thing there, which is this hole that we have here. So first of all, let's bring out what we have here. So I'm going to tick the part before you. So I'm not going to pause the video. So this will be a thick line. This will be a thick line, and this will also be a thick line from here to here. So this from here to here will be a thick line, and this will be a thick line. So as I've said that I have produced this in freehand sketching. I produced in freehand sketching. Watch the video, or you can sketch it free-handed. So and I said that why can repeat the same question, and they can make it a drawing in which you have to make use of your drawing instrument to produce the isometric view. So that's why I've decided to use the instrument to produce this after I've done that of the freehand sketching. Okay, so we are moving on. So the next thing that I'm going to do here, so I also need to make this thick from here to here. So this will also be a thick line from here to here, like this. Okay, so about to have thickened this part. Okay, so now, so let's produce the vertical part. So this is a thick line. So this will also be a thick line from here to here. So this will be a thick line from here to here. So this will be a thick line, and this will also be a thick line from here to here. So the next thing that we have is that this line is also a thick line, and this will be a thick line from here to here. Alright, so you can see that the shape has come out. This is how it will look. Okay, so the next thing that we are going to add is this hole that we have here. So the distance from this center to this end is 22.5 millimeters. 22.5 millimeters. And from here to here is also 22. Okay, it is 22.5 millimeters. So the total is 45. So I'm going to get that 22.5. So I'll just put my set square here. So putting my set square here. So this is 20. This is 22. So 22. This is 20. This is 21, 22. So 22.5 is here. Okay. So I'm going to use my set square to transfer it to the other side. So I'll transfer it like this. Okay, then distance from here to here now. So from here to here. Okay, so as we are given here. Okay, so distance so from here to here, so from here to this point is 30. This is 20 plus 5 plus 5. That's 30. So 30 by 2 that is 15. So I'll take a measurement of 15 millimeters. So this is 15 millimeters. So I will transfer this down. So this comes down like this. Alright, so the hole diameter is 20, so the radius will be 10. So from here, you take 10 millimeters to the left and 10 millimeters to the right. Then, so from here also, you take 10 millimeters up and 10 millimeters down. So we form a square. So it's very simple. So form a square here. Okay. All right. Alright, so we have formed the square as you can see. So all I need to do is to join the longest diagonal together. So join the longest diagonal together. Then I will connect this point together with this. So I will also connect this point. So this point together with this. I've done this several times. So for those who have watched my videos, should have seen the way I did the construction of isometric circle. So what we are trying to do is to draw an isometric circle. An isometric circle is not a normal circle, it's an ellipse. It's always an ellipse. So alright, so with this point that we have gotten, so the next thing that we are going to do, so this is four center method. We are going to make use of this point here, this point, this point, this point, and this point to get the isometric circle. So I put the pinpoint on my compass here and I will draw this. So take it easy. Okay. So I believe all that I've explained here is clear to you. So I'll also draw here from here. Alright, so I put the pinpoint on my compass here, extend it to this point here. I will draw from here. Okay. Alright, so we're almost done. So I will take it from here and alright, so the circle has come out, but with the thickness that we have here, so this is 15. Will I be able to see the other part in here? So let me see. So what I need to do if I draw this in from this point, so let me take 15 millimeters if that would be possible. No, that's not possible. So this is how we are going to leave it. So this is the isometric view of the object. So this is the orthographic views as we are given, and we have produced is isometric view. It's as simple as I've explained it here. All you need to do is to practice. Thank you for watching. Thank you for listening. God bless you.